All right. So this is our little topic or conversation on vertical circles. Okay. So the circles you have been doing so far, like with you did with the turntable lab, those were all level circles. Those circles, if I can kind of draw one, well, here, let's see if I can do this with the thing. So if we kind of look at it from like flat, it kind of looks like this, and it's rotating like that. And so we're kind of standing behind it right now, looking flat. Everything's level. Force of gravity is equal to the normal force because everything's level there. And the centripetal force just points towards the center of the circle. So if this was like the center of the circle, the centripetal force would point like so. You'd have your normal force and gravity pointing that way. It's pretty basic. This force that's pointing towards the center is some sort of force like friction, or in some cases, the kid holding onto a bar, or, there's some force there. All right. And like I said, the turntable lab is a perfect example of a level circle. A merry-go-round is a level circle. Another level circle could be, you driving your car around a corner. That's also a level circle. A vertical circle, which is what we're going to talk about now, is one that goes up and down. So now gravity plays a new and interesting role, because now gravity is actually going to be pointing towards the middle of the circle, or in some cases away from the middle of the circle. It is important to note that gravity is not a centrifugal force. That's still a fake force. All right. There is no force that pushes the object away to keep it in the circle. It just so happens that gravity sometimes points away from the center of the circle. However, it's not a centrifugal force. Okay. So that's important to still understand that we are not changing that definition. So the problem here runs into this. So if we have an object at the top of this circle, gravity points down, and it is the centripetal force, or FC. And so that's nice. But then down here at the bottom of the circle, it points away from the circle, and we would need a different force to point up, and it would be the addition of these two things that equaled the centripetal force. So gravity gets a little weird here, because in the one area, it's the centripetal force, but in the other area, it's actually working against the centripetal force. And so this really gets us a problem like, well, what are we going to call positive and negative? Is gravity a positive force? Because here it's the centripetal force, but here it's working against the centripetal force. It's in the opposite direction of the centripetal force. So how are we going to dictate what is positive and what is negative? I think you probably figured out that right, left, up, and down will not work for a circle, because the object on a circle is constantly changing direction. So that it just will not work at all. So what we're going to do is we're simply going to define it in an easier way. We want the centripetal force to always be positive. All right. That makes things much, much, much easier to deal with. So, and we always know that the centripetal force is the net force, so it's the addition of the forces. So that means that the force pointing towards the center of the circle is always the big force. This just simplifies everything, keeps it very simple. So for our purposes, we draw another circle over here. If the force points towards the center of the circle, that's going to be positive. If it points away from the center of the circle, it will be negative. And you will see forces like gravity, for instance. Here, gravity is a positive force, and here, gravity is a negative force. So you're really going to